In 1929, the astronomer Edwin Hubble observed that all of the galaxies are receding from one another. Incredibly, what Hubble had discovered was the expansion of the universe predicted on the basis of Einstein's general theory of relativity. This discovery has the astonishing implication that as one reverses the expansion and goes back in time, the universe becomes progressively denser until one arrives at a state called a singularity, which constitutes an edge or boundary to space-time itself. It marks the beginning of the universe. The Big Bang model thus describes a universe which is not eternal in the past, but which began to exist a finite time ago. Many attempts have been made to avert the absolute beginning predicted by the Big Bang model. But it's been the overwhelming verdict of the scientific community that none of them is more probable than the Big Bang theory. There is no mathematically consistent model which has been so successful in its predictions or is corroborated by the evidence as the traditional Big Bang theory. In sum, according to Stephen Hawking, almost everyone now believes that the universe and time itself had a beginning at the Big Bang. And that, of course, is the second premise of the cosmological argument. The fourth argument for the beginning of the universe is also a scientific argument, this one based on the thermodynamic properties of the universe. According to the second law of thermodynamics, processes taking place in a closed system tend towards states of higher entropy as their energy is used up. So what happens when the law is applied to the universe as a whole? The answer is grim. The evidence indicates overwhelmingly that the universe will expand forever. As it does, it will become increasingly cold, dark, dilute, and dead. The galaxies will turn their gas into stars, and the stars will burn out. Thereafter, protons will decay into positrons and electrons, so that space will be filled with a rarefied gas so thin that the distance between a positron and an electron will be about the size of the present galaxy. The entire mass of the universe will be nothing but a cold, thin gas of elementary particles and radiation, growing ever more dilute as it expands into the infinite darkness, a universe in ruins. But this raises the question, if in a finite amount of time the universe will achieve a cold, dark, dilute, and lifeless state, then why, if it has existed for infinite time, is it not now in such a state? If one is to avoid the conclusion that the universe has not in fact existed forever, one must find some scientifically plausible way to overturn the findings of physical cosmology so as to permit the universe to return to its youthful condition. But no realistic and plausible scenario is forthcoming. Most cosmologists therefore agree with physicist Paul Davies when he concludes that the universe's low entropy condition was simply put in as an initial condition at the moment of creation. On the basis of these four arguments, we have good grounds for affirming the second premise of the cosmological argument, namely that the universe began to exist. From the two premises, it follows logically that the universe has a cause.